So hi guys, welcome back to our mathematic vlog. So my name is Faifah Akasha.
My name is Hadi Fizullah.
I'm Hafi.
And our lovely group leader.
Hi, my name is Manaki Daniel, and now this is our group Mathematics about progression. Let's go!
Wow, Irfan, building these towers is really fun.
Yeah, I found it very interesting. But I wonder, Hafi, how many cups do we need in order to build the 7th tower?
You're right. And what is the total number of cups that we need to have in order to build all the 7 towers? You know what? Let's go ask Akif.
Yeah, I think that is a good idea.
First, I will tell a little bit about arithmetic progression. So basically, arithmetic progression have two formula, which is term of n and sum of n. Okay, firstly, let me see about the first formula. For the first formula, n term is Tn equal to a plus bracket n minus 1 bracket d. So Tn represent as number of term, a is represent a first term, and d is difference between two consecutive term. The next formula is Sn, which means sum of n. So the formula is n over 2 bracket 2a plus n minus 1 d.
Examples of arithmetic progression can be found in our classroom. The standard classroom table can fit 2 people, but if we combine 2 tables, we can fit 4. As we can see, as we increase the value of n by 1, we generate the next term with a common difference of 2 from the previous term. There are other applications of arithmetic progression, but this classroom table example is one that we face in our everyday lives.
So now, we will move on to the theory of geometric progression. Geometric progression is a series that has a common ratio between each term. A is the first term, and we have R as our common ratio. So, for example, we have these numbers 3, 6, 12 and 24. A is our first term, therefore A equals to 3. And now we find the common ratio between the numbers. So 3 to 6, the common ratio is times by 2. 6 to 12 is also times by 2. Therefore the common ratio for these numbers is 2. For example, if we were to find the 8th term, the formula is Tn equals to Arn minus 1. For example, we are finding the 8th term of this sequence. Therefore, we will get 3, 8, 4. Now, we will move on to the sum of geometric progression. It's a bit different from the arithmetic progression calculation of the sum. So, for the sum of geometric progression, we have 2 calculations, 2 formulas. The first one is Sn equals to A, our first term, times by 1 minus Rn. The R is our common ratio over 1 minus R. So this occurs, we use this formula when our common ratio is in between -1 and 1, and also when the common ratio, the modulus of the common ratio is less than 1. For the second one, Sn equals to A, our first term, times by Rn minus 1 over R minus 1. This is for when the ratio is other than in the range of larger than -1 or smaller than 1. So this formula is used when the modulus of R is larger than 1.
Okay, so for the geometric progression, there is one application that I can show you guys. Come on. Okay, so guys, can any of you help me bounce the ball very hard to the ground?
Yes, sure.
Okay. Please, shot. Wow, so hard. Very hard. So as you guys can see, the height of the ball will decrease by half each round. In geometric progression, we didn't use the common difference. We will use the common ratio. The common ratio is 1 over 2. That's why the height of the ball will decrease by half until the ball stops on the ground. So that is the application for geometric progression.